Lastly but not least, we have Kate Keeley, who's going to talk now. And slideshow and from the beginning. And here's your pointer.
And here's the pointer. Thank you so much.
Yeah.
Yeah, thanks very much for the introduction. I just wanted to add a quick note to that I'm actually a co-editor-in-chief of SoftwareX with my colleagues David Wallum from Oxford University and Randy Sobey from the Victoria University. And I also wanted to call out Frank Sinestra, who was one of the co-founders. So SoftwareX is a new journal that publishes software as opposed to articles, scientific articles. And what we do is we publish software as a scientific instrument. And to explain what we mean, I just wanted to give you a little bit of history, what we were thinking when we were starting the journal. So we were thinking about the great discoveries that were done over time, and they were done with the aid of scientific instruments. So here is one of the precursors of modern science, Antoine van Leeuwenhoek. He was a Dutch draper who also doubled in science and managed to construct a microscope, a new instrument that then facilitated and enabled really many significant landmark discoveries in microbiology. And here's another example, another scientist, British scientist, John Harrison, who designed the chronometer, right, that solved the problem of establishing longitude and latitude and enabled many geographical discoveries of its time. And so all those discoveries, so those are just two examples of many, many others. All those instruments at the time were recognized as a significant scientific contribution. So, for example, John Harrison here was awarded the Copley Medal by the Royal Society in recognition of his contribution to science, right? But if we now fast forward to modern times, something interesting happened. A lot of the scientific instruments we developed started getting developed in software, not something tangible, right? Software has this drawback, I don't know how to call it, that you can't really see it so well, right? It's not something that you can touch, it's very intangible. To the extent that one of my co-founders once talks to a colleague at CERN and about software as a scientific instrument, and that colleague said, well, software couldn't possibly be a scientific instrument because scientific instrument is made out of metal, right? So that shows that all of us have this mental image of what a scientific instrument is, and software just does not conform to it. But if we think of one of the greatest scientific discoveries of recent times, the discovery of gravitational waves, it was accomplished in large part because of many software scientific instruments that this research relied on. And in fact, I was trying to, just like with the chronometer and the microscope, I was trying to find logos of the various projects that developed those scientific instruments. And I kept finding them, and eventually I decided not to put them there because I figured I would leave somebody out, leave some important software out. And this is just a sign of the times, right? Today, scientific discoveries are very complex, much more complex than they used to be, and they are composed of many parts. They are not just one thing. So why do we publish software and data, right? So my colleague Chiara Farinelli, who is here on behalf of Elsevier, compiled these graphs from data from various interesting surveys. And the first one, let's see this, apparently, there we go. This graph here shows, maps the importance versus availability of various artifacts. So you see it's really important to have scientific articles, and they are also fairly available, easy to find them, right? Other things down here, maybe not so much. But if you look at software here, it's very important to find, it's very important to have, but it's not so easy to find, right? It's not so available. So what we're trying to do in SoftwareX is take it from here and put it somewhere up here, right, to make it much easier to find. And then also another survey showed that software right now is just very opaque, right? People most often have it, as you can see, a computer at work, on some portable storage carrier, a computer at home, right? So this is the highest availability of the software. And there's also a fascinating tech report from the University of Utah that actually cataloged all the different excuses that people for computer science articles give for why they can't give you their software, right? And they all boil down to essentially the dog ate my homework kind of excuse, right? Like, oh, the student left, oh, the project ended and we don't have the resources to debug the software anymore, and so forth and so on, right? So dog ate my homework kind of thing. And so how can we change that, right? So one of the underlying desires under SoftwareX is to make sure that we can publish software, that we can credit the authors, and that software doesn't have the rank of something that some technician did and made, that it's regarded as a first-class citizen scientific result, a scientific accomplishment. So for doing that, we, first of all, provide a repository. It's a GitHub repository where when you publish with SoftwareX, you can upload your software. And it's going to be available in that repository for all times, or, for all times that we can manage. So no longer the dog ate it, no longer a computer at work, computer at home, somewhere on the disk under this pile of paper. It's going to be available online to all comers. Secondly, it's going to be indexed, searchable, discoverable, so others can stand on your shoulders, right? And you can turn into a giant, right? The more people stand on your shoulder, the bigger shoulders you need to have, right? And then that it's also that there is that it's put in the context of an ecosystem where people can find it and combine it with other tools and data and so forth. So what is a SoftwareX article? How do we publish it? So first of all, we ask people to write a short article, very short article, 3,000 words that describes the impact of their software. It's really an impact statement, right? We publish software as a scientific instrument. Well, what was the software instrumental in, right? What important discoveries were made using this software? So just an impact statement. And then a metadata table. And the metadata table, you've got some examples over, no, wrong button. Oh, we're anticipating very significantly here. All right. Well, I didn't go as far as conclusions, but all right. So you've got some examples of the metadata here. It essentially tells us, or tells the readers, what the license is, where the software is available in that GitHub repository that I was talking about, and so forth and so on. And we've got code metadata, which is for the actual code. This is the required component. And then we also have software metadata. So in addition to code, you could also provide an executable of your work. All right, and so what is the submission process? Well, again, you submit an article that describes the impact of your software. In that article, we ask authors to discuss some background, so motivation and significance, the software description, the examples of the software used, but the most important part, the key part of that description is what was the impact of the software. Were there some important discoveries being made? Did it contribute to some work that is perhaps in process but recognized? Was it simply used by very many scientists for very many different discoveries, and is there evidence of that? And then we publish it as an open access with a fee of $500. It's a standard publishing fee. How is then a submission like that reviewed, right? So one thing that we don't do is we don't actually require reviewers to compile and run the software at this point. We're just sort of saying, well, if there was this important discovery made based on the software, and if, maybe 40,000 people downloaded it in a year, chances are that it runs, right? Important discovery, you can't do it in a code that doesn't run and that doesn't compile. We give reviewers a set of questions. So I'm just going through this because maybe some of you in the audience would like to volunteer to be reviewers. We're still looking for that. It's still very unusual to publish software. So if that catches anybody's eye, please let me know. You are given a template that tells you how to evaluate the software. So asks all sorts of questions about the quality of the software. Is there documentation? Is it open source? What is the license? How is the software tested? Are there daily regression runs and so forth and so on, right? So it's not like, oh my gosh, I'm given this to review and I don't really know how because nobody reviews software. You'll be given a lot of information about that. But again, the most important criterion is the impact, right? What are the important scientific discoveries that were done with that software? And so while reviewers are not expected at this point to compile and run, we do encourage authors to submit various videos or various other evidences of the fact that the software runs. And in particular, this is important if you publish a software that perhaps has a lot of potential for impact on science, but hasn't had that impact yet, right? Then we look more closely. And we're also, there's work in progress actually with CodeOcean, where we're trying to make it possible for the authors to upload the software to CodeOcean, and you just heard the presentation about how this works and how this is done, and then the reviewers could actually run and validate the software quite easily. So the idea here is that it would make it easier on the reviewer to review the software. It would also make it easier on the reader to then repeat that result or to build on that result, right? And so we're considering right now various incentive schemes for the authors to actually work with CodeOcean on this, various maybe badges or stars or things like that. All right, a few words about where we are with SoftwareX at this point. The journal started in 2015. The number of submissions was, roughly speaking, stable. The rejection rate has been going down, which is an interesting statistic because that means that it's becoming better understood what it means to submit software. It also becomes better understood what it is to review the software. In 2015, at the beginning, I had a lot of reviewers saying, read the article and say, well, it's an interesting piece of software, but there's no result. There's no graph. Right? In computer science articles in particular, people are expecting a graph. There's no graph, there's no result, right? So that's just as it should be. There should be no graph. There should be, this is the software as the result, right? And I think it's becoming a little bit more understood now what the SoftwareX publishes. And as you can see, we've got various different areas that are submitting to the SoftwareX. Relatively few submissions from humanities, arts and sciences, although there is software is increasingly used in areas like archaeology. So we're hoping this will improve. And the other areas are largely connected to mathematics, physics, and so forth. So very much engineering areas. Still a lot of software from computer science. And as you can see, number of published articles has been rising, number of citations has been rising, site score has been rising. And again, we're gold open access. So just a few parting thoughts to finish off. One thing that we're really hoping to address is there's the scientist's dilemma, right? Should I invest in making my research reproducible, increasing the quality of my research, or should I publish new research? Should I go chasing new ideas? And it's a really important dilemma, right? And why is it a dilemma? It's because making science reproducible right now is a lot of work, right? If it wasn't a lot of work, there would be no dilemma. You just check this box, you're done, right? But it is a lot of work. So should I do this, or should I chase new directions? Maybe there's a cure for cancer waiting to be discovered, but no, I have to make my software reproducible. So I talked to a lot of scientists. One of the things I do is also operate a national testbed for computer science research. I talked to a lot of scientists in that context, and it always boils down to that dilemma. And it's particularly heart-wrenching, I have to say, in the case of young faculty, of young scientists who are in their most creative years, and they have this problem with, they have to get tenure, they have to publish, and so forth and so on. So this positioning of the problem, though, gives some clues on how to solve it. First of all, new research. What is a new research? Is software a new result? right? Does it make sense? So again, giving the credit, the recognizing the impact, I think is an important way of solving that dilemma. But another important way is making reproducibility cost-effective, right? Like I said, if it's just, I will check the box, there is no dilemma. We've solved it. And some efforts for that, CodeOcean, obviously, making things cost-effective, making it easier to reproduce research. And like I mentioned, I'm operating a testbed for computer science research that gives computer science researchers bare metal reproducibility or bare metal access to nodes for developing new operating systems, new virtualization systems, and so on and so forth. And one of the things that we're trying now to do is we're recognizing that operating this testbed puts us in an interesting position. Because in fact, through our services, through the services that are running on the testbed, we know everything that the users are doing, right? They request certain resources, they claim that reservation, they deploy an image or reconfigure those resources in a certain way. All the resources on the testbed are versioned. All the images that they deploy on those resources are versioned. So if we consolidate this information that is already recorded in the testbed and filter it by what the user is doing, we can really tell the user, this is what you did since the beginning, since you entered the testbed, right? And if any of you are familiar with the Linux history command, when you type history on the Linux prompt, it gives you a list of all the Linux commands that you ran. So this is what we're trying to do right now with the testbed, is tell the user everything that they ran. And that is not necessarily the description of the experiment, because science is a little bit meandering. It wouldn't be hard if it was not, right? So, I was working on this, and this equation was very hard, and then my colleague came back from lunch, and then an apple fell on my head, right? Which of those things mattered in your scientific breakthrough? Well, you edit your history. But again, we're trying to lower the effort that it takes to make science reproducible. And with that, this is it.
Thank you very much. So I'd like to open the floor up for some questions. Do we have any questions? Well, while we're waiting, I did want to, I was very curious myself, and we've talked a lot about tools, about preprints, about protocols, about curating code and software, and now we have the technology and the means a lot of times to do this. There are solutions out in the market. How do we influence, or what are some ideas to influence user behavior? Because I think that's going to be the hardest part, is changing user behavior, right? So maybe do you want to take a stab at that?
Yeah, is this working? Yeah. So from my perspective, what it needs is obviously that we give credit to those that share these various components. It could be via citations itself. It could be via different output ways of beyond the actual paper. So SoftwareX is a good example of how you can actually publish a study based on your software that only describes the software itself, rather than some kind of scientific finding that's derived from using that software. And that also needs more systematic ways of accumulating citations to these kind of tools, that we can find out how many citations does this data set get, how many citations does that piece in CodeOcean get, and then that people also get positive feedback, that we move away from just looking at the papers, but looking at this entire ecosystem, and that also on the university side, committees and promotion committees recognize that this kind of sharing is something that is to be aspired. So what we also need to create is these kind of positive stories that show this package, this software, this data set was used many times, it had influenced the community, and that this is recognized, and that we share these kind of positive stories as well.
Excellent.
So I completely agree that we should work on making the carrot bigger, but we also should work on making the stick smaller, because right now the stick, the effort that it takes to make your research reproducible is huge, and the carrot is tiny, right? We need to invert those proportions. And so the other approach of making it as easy as checking a box to making the research reproducible, it would be good. If we could make it, in fact, cheaper for people to do research by making it reproducible than otherwise, that would be fantastic. And that doesn't seem like such a far-fetched idea if you consider that, for example, well, the student leaves your lab and, they left a little bit of code here and a little bit of code there, and that data is perhaps, on his dog's computer at home kind of thing. And you count now your next student wants to extend this research and it's hard. And all of a sudden you have to put a lot of cycles into this. Whereas if this was nicely wrapped up in a Docker container, for example, or a virtual machine or some kind of image, and your next student could come and start from something that they can already run, and the data is registered and the code is registered and they are all publicly available, that would save a lot of work. So if we can also persuade that this is actually a more efficient way of doing things that can lead to more discoveries, I think that would make a huge difference.
Anil?
I'd just like to add one more thing. I think that if authors will feel that the editors care about it, they will also care about it. So there's a lot of debate whether this should be mandatory or optional. So I think that it can be something in the middle. It can be optional, but when the authors sense that the editorial see that as has weight in some way, there's a range of things that will make the difference. I think.
I'll just add one more thing about carrots and sticks. I think you're absolutely right, Pierre, to say that this is about culture and behavior change. I would observe that historically there's been reticence about sharing these artifacts, particularly the data that stems from research that's collected, until it's fully mined out. If somebody thinks that they can publish 2 or 3 more articles based on the data that's been collected, then there's reticence about sharing that data with the first article. So I think we do have to think about the behaviors and the incentives and make sure that we're aligning those with the behaviors we want to see. Some of it is probably within the gift of funders to require certain forms of behavior and then insist on compliance, and those of us in the publishing business can help measure and manage the compliance. But I think we also have to be very careful about those sorts of mandates. I don't think publishers putting in place requirements that you can't publish without providing the data, that's probably the wrong part in the workflow to make that requirement. For example, IEEE has published some research that shows that inclusion of code and data with articles will typically increase the number of citations to that article by 3 times. And it's that kind of information that I think that we can provide as part of educating authors and reviewers that will help them to adopt the behaviors that we want to see more widespread. So I think it is all about incentives and aligning those with the outcomes we want to see, and not sticks. Maybe get rid of the sticks completely.
Well, I meant a different kind of stick.
Yeah. Any last questions? Yes. Go ahead, Hannah.
Thinking about the incentive ideas and the different players, thinking about funders and publishers, what do you all see as any opportunities for industry involvement to make this easier? Like I'm thinking maybe creators of reagents making protocols, maybe incentivizing those in some way so that people could click on a reagent and a protocol and be able to buy that. Or does that get too money?
Maybe yours is the best.
I think that I did some work previously in another life in that kind of field, actually, and I think yes, it's actually perfectly feasible to imagine that all kinds of data signatures can be preserved throughout the scholarly record. And I hesitate to use the dread phrase blockchain. Is there a prize for
avoiding it? Yeah.
But you know, there are systems that would allow you to preserve all of that data in a sort of chain of research activity, from the make and model and serial number of the instrument that you collected data on, to the QR code on the bottle from the Sigma Aldrich reagent, and have all the way down to the code and the runtime environment for the software that you analyzed data and results on, and to have that all fully available in the ecosystem that you're displayed. There's no reason for us not to think about that kind of scenario.
Yeah, I think you. Yeah, I mean, the more knowledge you have, the better it is. It's even batch numbers and these kind of details that are important. They need to be obviously driven by the scientific need and not the commercial need. But apart from that, definitely, I mean, it needs to be, everything needs to be traced and reproducible in the same way that people keep lab books.
Right. How about one quick last question and then okay.
Question for Kate in SoftwareX. So we used to encourage authors to supply their code and data routinely in our supplementary material. Would they be able to submit that to your journal?
No.
Since the code and all had already been
Not
available?
Not only would they be able to submit that, but would count this as a separate publication, right?
But this,
So
I want to make sure that wouldn't count as sort of
no.
pre-publication and thus disqualify them from being able to submit.
No. So this is what I said, right? The article, the short article that we ask authors to submit to SoftwareX is an impact statement. This is not the scientific result. The scientific results should still be published and we even have special issues that are joint with scientific journals that publish those results, and we publish the software that was used to obtain those results. Okay, so those are two separate publications.
Yeah. Well, I think we've run out of time, but I did want to thank our panel. Thank you very much, and thank SSP. Yeah.